Okay everyone, so in this video I will go through again how to draw an energy level diagram, or sometimes they call it an energy profile diagram. Honestly, I think it doesn't really matter. Okay, so energy profile diagram, energy level diagram supposed to show you what's the change in energy between the reactants and products, and also supposed to show you what's the activation energy of the reaction. Now, I do have a particular way of teaching my students how to draw this, so I hope you listen carefully because that will help you remember it better. So on the left, let's first look at an exothermic reaction. Now let's recall, exothermic. Does energy leave or the energy gain? So we remember at the bottom here, EX, exo, that means it's exit, so that means I get lesser. So firstly, I will draw a horizontal line, and this is the energy of the reactants. So my reactants start at this energy, and now my energy is lost, right? It's lost. So I started with $100 and I lose energy. Do you think I will have more or less energy eventually? Right, so if I lose energy, obviously my products would be over here, products. So you must write reactants and products, or what is the actual chemical name. Okay, so first draw these reactants and products, and then we will draw a hump because that is activation energy, and it will look like that. So when I go for reactant to products, this is the activation energy. Now, after that, we need to do a few labels, okay? And I want you all to only draw one dotted line, and this dotted line will start from the reactants. So you draw a dotted line to extend this line. We're trying to extend the reactant line like that, okay? We're trying to extend it. And there should be one dotted line and two arrows. So the first, all arrows must start from the dotted line because we want to know what is the change from the reactants to the products. So from here to the products, we draw an arrow. Please draw only a single red head arrow. So from the reactants down to the products, and an arrow like that, right? Please no double-headed arrows. That means this is absolutely wrong. No. Okay? Really no. So please do not draw this. Now, what is this? This is the enthalpy change from the reactants to the products. So this is labeled as delta H, and we write this is a negative value. Okay, delta H, negative value. This is the enthalpy change. Now, the activation energy is the amount of energy required for the reaction to start. So this is from the reactants to the top of the hill. This is activation energy. Let's label it well. Okay, so this is activation energy, and that's enthalpy change. Right, so this is for exothermic reaction. Let's try for endothermic reaction. Okay, so the one on the right. So let's start with the same level, the reactants. Alright, now in this case, endothermic, EN, endo stands for enter. So the energy enters. I started with $100, you give me some more money, so obviously my energy at the end needs to be higher. So then this is product. Okay, so then I draw a hump again. So the hump will look like this, slightly different. That's the next step. Now remember, only one dotted line and two arrows. So the dotted line always starts from reactant, and all arrows start from dotted line. So first from the dotted line to the product, single arrow, this is my delta H, my enthalpy change, and this time it will be positive, so equals to plus, positive. And then from the dotted line all the way to the top, and this is my activation energy. Okay, so this is how we draw the energy profile diagrams. So what we know is that let's look at this one, the exothermic. So we have the reactant to form the product. So in this case, reactant to product, the reaction will start from the reactant, get enough energy to overcome activation energy, and then from the products. So therefore, the enthalpy change of the products is like that. Okay. However, if we consider the backward reaction, that means we go from products to reactants. Now I'm going to draw in blue. So I go from products to reactants. So now the products are actually now the reactants. And then the reactant is actually now the product. So in the backward reaction, right, from the product to the dotted line, now this is the enthalpy change now. And now it's going up. So this time the enthalpy change is positive. And this is the backward reaction. Okay, this backward reaction doesn't come up very often, but I think it's important for you to understand the concept. Now for activation energy, imagine that the forward reaction, there's a ball here. In order for the ball to go over to the other side, it needs to first climb up this amount. Now, what happens if I start from the products now? How much energy does the ball need to go from the products in order to go to the other side? So that's the activation energy. So activation energy is therefore from here and go all the way up here. So using the blue line, activation energy this time is from the products all the way to the top. So this is the activation energy, EA, of the backward reaction. Okay, so this backward reaction, forward reaction thing is a little more advanced, but please don't let it confuse you from the usual forward reaction. Alright, drawing this type of diagrams are very important. Most of the time they give you 2 or 3 marks and it's actually quite straightforward to get. So I hope that you'll be okay and I hope this is helpful for you. Okay, thanks. Bye.